Okay, ladies and gentlemen, the last time we were together, we were learning about moles, okay? And we know that 1 mole of anything is equal to 6.022 times 10 to the 23 particles. Okay, and practically, like in real life, that doesn't really help us very much. So, because we are moving to the online learning and we are, trying to simplify chemistry right now, we're not going to necessarily use this number in any of our calculations going forward. We're going to just simply concern ourselves with the fact that 1 mole is also equal to the molar mass of something. That is, that 1 mole of some sort of substance, its mass is the same as the elements that make it up on the periodic table. Okay, so let's say so the only kind of conversions we're going to be doing for moles right now, at least in the next couple of minutes, is moles to mass and mass to moles. Now, this mass can be of single elements, or it can be of compounds. And just to give you a little bit of review, let's practice calculating the molar mass of something. Okay, so let's practice calculating the molar mass of magnesium nitrate. Okay, so you're going to need your periodic table and your polyatomic sheet. If you don't have those, I did post them in resources, the resources area on Google Classroom. Okay, so magnesium nitrate. So MgNO3 2. That's magnesium nitrate. And we're trying to figure out its molar mass. Okay, well, I have 1 magnesium. I have 2 times 1 nitrogen, so that's 2 nitrogens. And now I've got, erase this little thing here, 3 times 2. Oh, look at that little smiley face, how cute. 3 times 2, which is 6 oxygens. Okay, so magnesium, let me look at my periodic table here, because I'm a little out of practice. 24.305, that's for one of them. Each nitrogen is 14.007, and 6 oxygens are 15.999 each. Okay, I do want you still using my periodic table, so I did post it for you. You can pull it up on your screen so that we're correct with our number, like the kind of numbers that we're using. Okay, so 24.305. We've got 28.014. And get my calculator out for this. Just doing the rest of it in my head like a champion. We've got 6 times 15.999, 95.994. We add all these puppies up, 28.014 plus 24.305. Okay, this gives us a molar mass for magnesium nitrate as 148.313. Okay, so what can we do with this? So let's say my first question is, how many moles are there in 27.5 grams of MgNO3 2? Okay, so we are given a mass and we're asked for moles. And 1 mole of anything is equal to its molar mass. Okay, and if we could just take a look up here, this is how much 1 mole of magnesium nitrate weighs. So we can expect our answer to be less than 1 mole. Okay, so let's switch. So we're going to start with what we're given. We have 27.5 grams of magnesium nitrate. Okay, and I want to get rid of grams and get moles. So in 1 mole of magnesium nitrate, there are 148.313 grams of magnesium nitrate. Okay, so I'm going to take 27.5 divided by 148.313. So the calculator gives me 0.185418 whatever. This number here, my number I started with, has 3 sig figs. So I'm going to round my answer to 3 sig figs. So it's 0.185 moles. Okay. So now let's just do a simple one. Let's say I've got 1.8 moles of titanium. Well, and I want to know how many grams do I have of titanium. The molar mass of titanium is 47.88 grams. Okay, so we want to get rid of moles and get grams. So we have 1.8 moles of titanium. Get rid of moles. So in 1 mole of titanium, there are 47.88 grams of titanium. Okay, so I'm just going to do a sig fig count right now. 2 here, 4 here. Notice that my mass, your mass doesn't always go either in the top or in the bottom. Here, my first problem, my mass is here in the bottom. But here, my mass is up at the top. But you're putting things such that the units cancel out. So grams was on the top here, so that's why grams is on the bottom here to cancel out. Moles is on the top here. That's why moles is down here. Okay. All right, so let's do this math. 1.8 times 47.88 equals, turn this back to black. All right, we have 2 sig figs in our answer. It gives me 86 grams of titanium. Okay, so I'm going to put up a problem here and give you a second to solve it, or you just actually pause it because you have that technology. All right, so I have 18.74 grams of, let me pick something good. K2SO4, and I want to know how many moles I have. Okay, so if you don't want to see me solve this right now, if you want to try this on your own, hit pause. So the first thing that I'm going to do is I'm going to figure out what my molar mass of potassium is. So I've got no I don't. I've got 2 potassiums, and they each weigh 39.098 grams. We've got 1 sulfur, which is 32.06 grams, and 4 oxygens, which are 15 0.999 each. Get my calculator going. So 39.098 times dose, 78.196, 32.06, 63.996. Okay, we add them all together. Notice here, I'm not really going to give you a hard time with sig figs this year for the rest of the year, so you don't really need to worry about it. But this 32.06 ends here at the hundredths place, so your answer should really only go out to the hundredths place. Okay, so this comes out to be 174.252, which we will round to 174.25. Okay, so I didn't even solve my problem yet. All I did was get my molar mass. So we have 18.74 grams of potassium sulfate, K2SO4, and we want to get the number of moles. Well, there are 174.25 grams of potassium sulfate in 1 mole of potassium sulfate. So notice that we're no longer going to be doing any of those 3-step conversions because we're not involving atoms, molecules, particles at all. Okay, so we're going to do 18.74. Since grams is on the top, we're putting grams on the bottom. Divided by 174.25. That gets me 0, ooh, I'm in red right now, 0. And it's 4 sig figs I'm allowed, 0.1075 moles of K2SO4. Okay, so that is practice with just, we just went moles to mass and back. So if you're, and here's just a little quick trick. Okay, if you're going from moles to mass, you're going to multiply by the molar mass. And if you're going from mass to moles, you're going to divide by the molar mass. Okay, so you're going to be doing some practice problems and turning those in on Google Classroom. I'm going to just put a list on a Google Doc, and what I want you to do is to solve them, show all your work, and take a picture, submit it. Okay? All right, bye.